In this video, we are going to see how a column is designed for its moment and its vertical load. Generally, there are two aspects to record to be considered. One is whether the column is a short column or a long column. Moment, how the column moment is calculated. Actually, the correct method of calculating the column moment is the moment distribution method. That we shall see in another video. Now we are going to take the column moment as equal to 0.4 into the maximum bending moment in the beam which rests on the column. So this empirical method is approximately maybe uh, near to requirement. So based on that, we are going to design the column in a Excel sheet in a computer. Please continue the video.
Now we are going to see the column main rod design for the column A3. This axial load on the column is this one 785.32. We are going to use the concrete M20 and steel Fe500. So the characteristics of concrete and steel are 20 and 500. So breadth of the column, we are going to assume this as 230 mm. The depth of concrete, the other dimension of column is we are assuming as 450 mm. The cover reinforcement is generally provided as 40 mm sometimes. For non-coastal area, this can be taken as 35 mm. These are the something. These are assumed things. Now we are going to the design aspect. So maximum bending moment in the column is the required thing which is required to be found out, which is the main thing for this. For this we have already arrived taken a conclusion that the bending moment on the beam which is supported by the column is multiplied by 0.4 or 40% of the maximum bending moment available on the beam is taken as the column bending moment. This has been tried in many ways by our exact analysis through moment distribution method. So for the time being, you can take this. So the working column moment, that is the maximum bending moment in the beam, is 147.82. This is 40% of this is 59.12 kilonewton meter. Okay, and another one condition is given in IS 456, which is the minimum eccentricity in any column should be taken as 20 mm. So if it is taken into converted into meter, this is 0.02 meter, 2 centimeter approximately. So multiplying the distance into the load is the moment in that column. That is as axial load is 785.32. 785.32 is the axial load. 785.32 into the distance 0.02. The value comes as 15.7 kilonewton meter. So between these two, the previous calculation, it comes as 59 something. Now the minimum eccentricity is due to minimum eccentricity, it is 15.7. To maximum we are going to take, so you take this as the applicable column moment. So this is the column moment, and this one is the axial load. So for this we should calculate what is the factored load and factored bending moment. So it is 785.32 is the axial load into 0.1.50% added. This value comes as this. This is the factored axial load. As well, the bending moment is 59.128 is the working bending moment. Add with multiply with 1.5 or add 50%. This comes as 88.69 Newton meter. Okay, these things analysis we are completing with this. Now we are going to design part. Design part means calculating the reinforcement. Now we need three type of calculations. One is this one, another is this one, another is this one. Why this is required? D dash by D is required, PU by FCK BD is required, MU by FCK BD square is required. Why it is required? We are going to use a table, that is chart of this type. In this, the x-axis is MU by FCK BD square, y-axis is FU by FCK BD. In this, a curve has been written for every type of reinforcement percentage. That curve is defined as P by FCK. P by FCK. P means the percentage of reinforcement. By FCK equal to 20, 24, is 26, 24, 22, point 0.2, 0.18, 0.16, 0.14, like this. A curve has been given by the given in SP 16. So for using this chart, we are calculating these items. On calculating this, D dash by D is 35 by 450. This value comes as this. Then PU means the maximum axial load. FCK is that is the character strength of concrete. B is breadth, D is depth. This is the calculation method. On calculating this, this value comes as this. As well, MU is maximum or ultimate bending moment in the column. So on calculation of this value, this fraction comes like this: 0.1, 0.57 for D dash by DD value of 0.08. Now we are going to the tabulation: 0.1, 0.57. This is 0.1 MU by FCK, 0.1 we are going to calculate. For this we are going to 0.57. Next is vertical column is 0.57. 52, 54, 56, 57. So intersection of these 2 points comes here. Okay. This curve is approximately near to 0.12 PU by FCK value. This is PU by FCK BD square value is 0.12. PU by FCK as per chart number 44 of SP 16, this is 0.12. So PU by FCK is this much. Therefore, what is P? P means percentage of reinforcement in the concrete. This comes as 2.4 on calculation. This is on percentage. Percentage of what? The cross section of column. 230 is the width, 450 is the depth, into 2.4%. The value comes as this much square mm. Then this is the rod area, 12 mm rod, this much square mm, this much square, 16 mm, this much square mm. So by using 12 number of 16 mm rods, the total square mm used will be 2411 square mm. Required is 2484. This is somewhere near only. It is approximately about 65 mm square is lesser. There is no problem. We can use it. So 12 number of 16 mm rods are required for this column. So coming to this section, the reinforcement. This is compression member with bending rectangular section, reinforcement distributed equally on all 4 sides. So equal reinforcement on all the 4 sides. So you keep it reinforcement approximately on in all the 4. 12 rods. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 12 rods we are using. This in this way the rods may be arranged.